Hello everyone, welcome to the MadStem Science Summer Camp, hosted by Middleton Robotics. I'm your resident mad scientist, Leo, and today we're going to be talking about Newton's laws of motion. Now, Isaac Newton, for whom the laws are named, was a pretty famous scientist back in the day, and he did many things. Today, we're going to be talking about how he observed motion. Now, the laws of motion are scientific laws. Scientific laws aren't like regular laws like don't steal, as these physically cannot be broken. They are always true and they're always true. And today we're going to talk about 3 such laws that he observed about motion. Now, the first law of motion states that all matter has inertia. Inertia is the tendency of mass to continue doing what it's already doing. That means that if something's moving, it wants to keep moving, and if something's still, it wants to stay still. Now, this is true. This is always true, but you can change this, and you can change this by acting on an external force. This is why the first law states that an object in motion stays in motion, and an object at rest stays at rest, unless acted on by an external force. Now, let's take a look at our basketball. Right here, it's staying pretty still. There's no forces acting on it. However, if we apply a force to it, it goes in motion, and it keeps going until, well, as I caught it, I applied another force to it. Now, you may be thinking, well, if that's true, if things want to keep moving, then, why doesn't the basketball roll forever? It looks like it's slowing down here. And that's because of something called friction. Now, friction is an invisible force. So inertia is true because an external force is acting on the basketball. The force is called friction. Now, friction is when two objects collide, they cause friction, and friction, it changes that energy of motion that it has into energy of heat, well, causing it to slow down. And this is true of all objects. A basketball on the table, if you wave your hand through the air, you can feel it, and well, between anything, and it's always there, and that's why, well, the floor doesn't feel like ice. Now, the second law of motion is about acceleration. Now, acceleration is, well, how is the change in motion? So if something's slowing up or slowing down, it has acceleration. Now, the second law states precisely that acceleration of an object is directly proportional to the force applied and inversely proportional to the mass of the object. Now, I know those are some fancy words, but let's break that down. What it means by that's directly proportional to the force applied, that means that if I apply a small force, it accelerates slowly. If I apply a large force, it accelerates more quickly. Now, it also states that it's inversely proportional to the mass of the object. Now, let's take 2 objects of different masses. We have this tennis ball, which has less mass, and this basketball, which has greater mass. If I apply the same force to them, we can see that the basketball, well, accelerates less. And this is because it has a larger mass, and therefore the acceleration for it is smaller. Now we're on to the third and final of Newton's laws of motion. It states that for every action, there's an equal and opposite reaction. Now, the wording on this definitely confused me for a bit when I was first learning it. But what it boils down to is that an object cannot apply a force to another object and remain exactly as it was before. When you apply force to 2 objects force each other. One object does not force another. So what that means is, if I throw this tennis ball up into the air, while the same amount of force that I put into the tennis ball throwing it up, the tennis ball also put down on my hand, and that's the resistance I feel when I throw it. Now let me show you this with a baseball and a basketball. If I roll the baseball towards the basketball, we can see that the basketball, well, when it was hit, it moved backwards, but the baseball, when it hit, also moved backwards. And this is because, and it was the same amount of force there. While it may look like different speeds, we know because of the second law of motion that they have different masses, so they're going to accelerate differently. In review, in today's video, we learned about scientific laws in general, and the three of Newton's laws of motion. Now, these were the first law, that an object in motion stays in motion, and an object at rest stays at rest unless acted on by an external force. Newton's second law of motion, that the acceleration an object experiences is directly proportional to the force applied and inversely proportional to the mass of the object. And finally, the third law of motion, that for every action, there is an equal and opposite reaction. Thanks for watching this video on Newton's laws of motion. Are you able to think of any examples yourself? Make sure to catch our other camp videos for more fun experiments and science.